Hello friends, welcome to Yashwantrao Chauhan Maharashtra Open University Nashik, School of Architecture, Science and Technology. In this video, we will continue our discussion on the program V92 BSc Physics Chemistry Mathematics, course S41441, Mathematics 04, which is of groups and rings. Myself, Tejasvi Kadam, work as an academic coordinator in the School of Architecture, Science and Technology, Yashwantrao Chauhan Maharashtra Open University, Nashik. Now, we will continue our further discussion on Credit 01, Groups, Unit 01.01, Binary Operation Defined on a Set. In this lecture, we will try to understand the concept of complex numbers now. R denotes the set of all real numbers. We are familiar with this set. We also know that N, the set of natural numbers, is the subset of R, that is the set of real numbers. That is, set of the numbers 1, 2, 3 is a subset of R. Z, the set of integers, is also subset of R. That is the numbers -3, -2, -1, 0, 1, 2, 3 and so on is the subset of real numbers. Also, Q, the set of rational numbers, is also subset of real numbers. Rational numbers are of the form P by Q, where P, Q are the integers and Q is a non-zero integer. This is also a subset of real numbers. Irrational numbers is also a subset of real numbers. Irrational numbers are the real numbers which are not rational numbers. So, in this way, we have studied that natural numbers, integers, rational, irrationals, these all are the real numbers. We have studied various algebraic operations on real numbers. We know that addition of real numbers is again a real number. That is, if we add any two real numbers, we will get the real number. Subtraction of real numbers is also a real number. That is, if we subtract real numbers, then output of that operation is again a real number. In the similar way, multiplication of real numbers is also a real number. That is, output of multiplication of real numbers is also a real number. Also, division of non-zero real numbers is also a real number. Here we are considering non-zero real numbers because we cannot divide any number by 0. In this way, output of the operations such as addition, subtraction, multiplication, division of the real numbers is again a real number. Is square root of any real number is again a real number? Then answer of this question is no. Square root of every real number need not be a real number. We will see this by an example. Consider any negative real number. Here we are considering a simplest real number, negative real number, that is -1. We know that root of -1 does not belong to set of real numbers. That is, there does not exist any real number which has the square -1. In general, we can say that root of -x does not belong to set of real numbers, where x is any positive real number. That is, it is impossible to find the square root of a negative number in the set of real numbers. This is the limitation of this set of real numbers. This leads to the extension of real number system to the complex numbers. Set of real numbers is extended to the set of complex numbers with the help of the number square root of a -1, which is denoted as I, known as imaginary number. Now we will see the structure of complex numbers. Set of all complex numbers is denoted by C. It is equal to set of the numbers Z is equal to x plus iy, where x and y are the real numbers and I is equal to square root of -1. Here I is known as an imaginary number. So, in this way, set of complex numbers is formed with the help of real numbers and imaginary number. In this way, any number of the form z is equal to x plus iy, where x and y are the real numbers and I is equal to square root of -1, that is an imaginary number, is called as a complex number. It is advantageous to express a complex number z as an order pair of real numbers. That is, we can express any complex number as an order pair of real numbers. Suppose z is equal to x plus iy, then this number can be expressed as order pair xy. So, z is equal to x plus iy is equal to an order pair xy. Now we will consider one note. Let z is equal to x plus iy be any complex number. We know that in this complex number, x and y are the real numbers and I is an imaginary number. So, in this complex number, x is known as real part and y is known as imaginary part. That is, in general, in any complex number, the real number which is separate is known as a real part and the real number which is multiplied by I is known as imaginary part of that complex number. We can also represent this complex number as an order pair xy, that is an order pair of real numbers. In this order pair, first real number represents real part and the second real number represents the imaginary part of the complex number. So, in this way, every complex number has two parts, real part and imaginary part. We will see one illustration. Let z is equal to 3 plus 2i. This is a complex number because 3 and 2 are the real numbers and I is an imaginary number. So we can say that 3 is a real part of the z and 2 is an imaginary part of the z. As it is multiplied by an I, that is an imaginary number. Now we will try to visualize a complex number using geometric representation. Any complex number can be represented as a point in a plane R square, that is nothing but a complex plane. Y-axis of the plane R square is known as an imaginary axis and x-axis is known as a real axis of the complex plane. Z is equal to 3 plus I2. In this number, 3 is a real part. We will plot this as an x coordinator on the real axis and imaginary part will be plotted on imaginary axis as a y coordinate. So in this way, using this real part and imaginary part, we will get the point in the R square, that is 3, 2. So in general, real part of a complex number represents the coordinate on real axis and imaginary part of a complex numbers represent a coordinate on imaginary axis. With the help of these two coordinates, we can plot any complex number in a complex plane. Now we will see one exercise. Verify whether the given numbers are the complex or not and find the real and imaginary parts of the numbers. So we will start with the first example. Z is equal to 3 plus I4. By the definition of complex number, we can say that it is a complex number because 3 and 4 are the real numbers. Here real part is equal to 3 and imaginary part is equal to 4. Now see this next example. Z is equal to 1 by 2 plus I 6 by 10. So by the definition, this is also a complex number because 1 by 2 and 6 by 10 are the real numbers. So real part is equal to 1 by 2 and imaginary part is equal to 6 by 10. Here we can easily verify these numbers because these numbers are in the form of x plus iy, where x and y are the real numbers. Consider next example. z is equal to 10. Let us check the answer. It is a complex number. Now we will see how it is a complex number. We know that z is equal to 10 can be represented as 10 plus I0, because if we multiplied any number by 0, we will get 0. So here real part of this number is 10 and imaginary part is a 0. In this way we can represent this number as a complex number, that is in the form of x plus iy. From this example we will see general note. If x belongs to R be any real number, then x belongs to C, that is x is a complex number, because x is equal to x plus I0, where x and 0 are the real numbers. Because we have given x belongs to R and we know that 0 is a real number. So we can represent any real number in the form of complex number. So we can say that every real number is a complex number. Next example, z is equal to I5. Let us check the answer. It is also a complex number. How is it complex number? Z is equal to I5 can be written as a 0 plus I5. So here it can be expressed as a x plus iy, where x and y are the real numbers. Here x, that is real part, is equal to 0 and y, that is imaginary part, is equal to 5. In this complex number, real part is equal to 0. In general, in any complex number where real part is equal to 0 is known as a purely imaginary complex number. So this is a purely imaginary number. In the next lecture, we will discuss upon the topic algebraic operations on complex numbers. Thank you.